In this video, we're looking at example 2 from section 3.5. We're going to understand how a multiple zero can affect the graph. So the question we're asked is, how does a multiple zero affect the graph of a polynomial function? And what we're told here is the multiplicity of a zero of a polynomial function is the number of times its related factor appears in the factor form of a polynomial. So really what you're kind of looking at is the exponents, how many times it would appear that way. And they want you to notice the behavior of each graph as it approaches the x-axis. What can you conclude about the multiplicity of a zero and its effect on the graph of the function? So what we're going to find is that the multiplicity does affect what the graph looks like as it approaches the zero. So if I'm looking at, let's say this first graph here, I notice that I have x minus 1 and x plus 2. So that means my zeros would be negative 2. So let's highlight that here. That would be negative 2. And the other zero will be a positive 1. And they're not shown, but each one of these has an exponent of 1. So at x minus 1, with an exponent of 1, so that means the multiplicity is 1, at your graph, as it goes through that 0, all that's happening is it's doing exactly that. It's going through the 0. So it's passing through. So we're just going to make a note that it is passing through. Now at x plus 2, again, we have a multiplicity of 0. If we look at the graph itself, all right, what's going on there? Well, same thing. My graph is passing through at that point. So we're just going to make a little note. If I look at graph number 2, they're not, actually, let me number them. So we'll call this graph 1, 2, 3, and 4. So if we look at graph 2, same thing. We have x minus 1 again, and x plus 2. And you'll notice that they're all the same. If we look at graph 3, it's x minus 1, x plus 2, x minus 1, x plus 2 for graph 4. But what does change is this 2, this exponent, or what will affect and count as the multiplicity of that 0. So once again, x minus 1, you have a 0 at positive 1, and x plus 2, you have a 0 at positive 2. But you'll notice now the multiplicity of 2 at x minus 1, if we're looking here, we no longer pass through that x-axis. We didn't go through that 0. We turned. Okay, so our graph turned at that point. And at x plus 2, the same thing happened as our first graph because the multiplicity didn't change. We still passed through. So we'll say passing through. All right, and this kind of seems, elementary, but there will be a point to this and you'll get it. In graph 3, x minus 1 this time has a multiplicity of 3. And if we look at that 0 of 1, it does kind of curve a little bit. It changes shape from graphs 1 and 2, but it still passes through. All right, so at x minus 1, we're passing through that point. And then x plus 2, nothing about x plus 2 changed. We still have that multiplicity of 1. So you can see there that even though x minus 1's multiplicity is changing, the x plus 2 value is not changing. So, or the behavior of the x plus 2 0 is not changing. Wrote the wrong phrase. So x plus 2 is still passing through. Can't spell either. And then finally, graph 4, x minus 1 now has a multiplicity of 4. And if we go to that 0, which is here, again, the actual shape of kind of the graph that's there is changing. It doesn't quite look like examples 1, 2, or 3. However, we can see that it's we're turning at that point. Okay, so when we get to the 0 of 1, the graph is turning back and it's increasing. It went from decreasing to increasing, but it didn't actually pass through that 0 of the x-axis. So here, our graph, let's stick to the same colors, our graph turned. X plus 2, the same thing has happened that it's been happening the entire time. It is passing through. All right, so what can we gather from this? What can we kind of figure out? Well, hopefully what you may have noticed is that here and here in graphs 1 and 3, where I've highlighted this in pink, our exponent or a multiplicity is an odd number, and that meant that it passed through. Oops. Having trouble here. Passed through the graph. And if I look at the x plus 2's multiplicities, all of those were 1s. And again, all of the x plus 2 zeros pass through. Now, the graph 2, where I had a multiplicity of 2 for the x minus 1, and graph 4, where I had a multiplicity of 4 for the x minus 1, those graphs turned. So what can we take away from this? Is that, when the multiplicity of the 0 of A is odd, okay, so 1, 3, 5, 7, 9, those numbers, the function, can't write today, the function crosses the x-axis. All right, and that's our pink ones. All right, we had those odd ones. So when the multiplicity of a 0 is odd, the function crosses the x-axis. Now, when the multiplicity of a 0 is even, well, kind of not the opposite, but something different will happen. The graph has a turning point. At the x-axis, right, where that 0 would be. And we highlight that one in gray. So when the multiplicity of a 0 is even, the graph has a turning point at the x-axis. And that's really all you need to take away from this example, is whether the graph is going to cross the x-axis or whether it's going to have a turning point at that point. And once again, the turning points, we had one here and we had one here. All right. So like I said, pretty simple to understand once it's kind of drawn out and sketched out and pointed out to you. But really the multiplicity of the 0 affects what the graph looks like when it approaches the zeros, whether it crosses through or whether it's going to have a turning point at that x-axis. Right. Give try number 2 the triads and see what you can determine the graph will look like at each of those zeros.